Hi, in this session we will discuss about REST and data modeling concepts. So at the previous session we have covered the OData services, like what is the OData service, how we can see the web service as a URL, and how we can see the metadata of a OData. Now in this session we will cover REST. So first of all, what is REST? REST stands for Representational State Transfer. It relies on a stateless client-server cacheable communications protocol, and in virtually all the cases the HTTP protocol is used. REST is an architecture style for designing the networked applications. The idea is that rather than using the complex mechanisms such as CORBA, RPC or SOAP to connect between machines, simple HTTP is used to make calls between machines. So in many ways the World Wide Web itself, based on the HTTP, can be viewed as a REST based architecture. So basically it uses the HTTP request to post the data. So the RESTful applications use HTTP request to create and or update, to read data and to delete data. Thus, REST uses HTTP for all four CRUD operations. When we say the CRUD operations, it means that for all create, read, update or delete operations. REST is a lightweight alternative to mechanisms like RPC, which stands for the Remote Procedure Calls, and web services like SOAP, WSDL, etc. So despite being simple, REST is fully featured. There is basically nothing you can do in web services that can't be done in a RESTful architecture. So basically REST is providing us with all the features which are available in the any other web services. REST is not a standard. There will never be a W3C recommendation for REST. For example, while there are REST programming frameworks, working with REST is so simple that you can often roll your own with standard library features in languages like Perl, Java or C++. Now, REST is actually act as a lightweight web service. So as a programming approach, REST is a lightweight alternative to web services and RPC. So much like web services, a REST service is a platform independent. That means you don't care if the server is Unix, the client is a Mac or anything else. So it is language independent. So C can talk to Java, etc. So this kind of functionality, that means that REST is a language independent. It do not rely on a particular language. So it is standards based. That is, it runs on top of HTTP. And also it can be easily used in the presence of firewalls. So like web services, REST offers no built-in security features, encryption, session management, QoS guarantees, etc. But all as with web services, these can be added by building on top of HTTP. So for security, the username and the password tokens are often used. For encryption, REST can be used on top of HTTPS, that is a secure socket. So one thing that is not the part of a good REST design is the cookies. So in REST, the ST stands for the state transfer, and in a good REST design, the operations are self-contained and each request carries with it all the information that the server needs in order to complete it. So basically my REST is a lightweight alternative to my web services, which do not offer any built-in security features or the encryption features, but yes, definitely these can be added by building them on the top of HTTP. So let's move to the next slide now. So what are the key components? What are the key components of my REST architecture? So my key components of the REST architecture are resources, a web of resources, client server, no connection state, and proxy server. So what does that mean? So first of all, let's start with the resources. Resources which are identified by logical URLs. Both state and the functionality are represented using the resources. So the logical URLs, simply that the resources are universally addressable by other parts of the system. and the resources are the key element of a true RESTful design, as opposed to the methods or the services used in RPC and SOAP web services. You do not issue a get product name and then a get product price RPC calls in REST. Rather, you have to view the product data as a resource, and this resource should contain all the required information or the links to it. Then comes to the web of resources. A web of resources meaning that a single resource should not be large and contain too fine-grained details. Whenever relevant, a resource should contain links to the additional information, just as in the web pages. So basically, when we say a web of resources, it means that we should not add whole information to a single resource and to make it a fine-grained detail. Rather, we should choose an option to create a resource using the links to the additional information. So that's why we call it as a web of resources. After that, the system has a client server, but of course one component server can be another component's client. Then there is no connection state. Interaction is stateless, although the servers and the resources can of course be stateful, but the interaction has to be stateless. Each new request should carry all the information required to complete it and must not rely on the previous interactions with the same client. After that, we have it is cacheable. So the resources should be cacheable whenever possible. So it should carry the expiration date and the time. So the protocol must allow the server to explicitly specify which resources may be cached and for how long. So since the HTTP is universally used as the REST protocol, the HTTP cache control headers are used for this purpose. So the clients must respect the server's cache specification for each resource. Then comes the proxy servers. So the proxy servers can be used as part of the architecture to improve the performance and scalability. So any standard HTTP proxy can be used for this purpose. So your application can use REST services without being a REST architecture by itself. For example, a single machine non-REST program can access the third-party REST services. So these are basically the major components of a REST architecture. Now, what is a OData channel? So basically in the previous session we have discussed what is OData. Now let's discuss the OData channel in more detail. So the runtime processing is handled by the data provider classes, that is a DPC, that are assigned to the object models. So my OData channel, that is ODC for SAP Gateway, will allow us to develop the content by defining the object models and registering a corresponding runtime data provider class. So there are two ODC application components, the business data provider and the metadata provider. So an ODC data provider implements a single interface that is very close to the OData protocol. So the OData channel application obtain access to common framework services. Let's take an example, logging or transaction handling using a set of agents called common service exposure. So these agents wrap the existing framework services in a way that OData channel applications can easily consume. So for SAP NetWeaver systems which are lower than the SAP NetWeaver 7.4, we need to install the software component, that is IW_BEP, either on the SAP Gateway system or on the SAP Business Suite backend system. But for the NetWeaver systems which are on the 7.4 or higher, the component, that is SAP_GWFND, is installed as standard, and it will include the functional scope of IW_BEP. So what does that mean is that for the NetWeaver 7.3 or below, we have to install IW_BEP for this. But for the systems which are on the 7.4 or higher, we already have a component which is a SAP_GWFND, which will come with the default configuration. Then what is a content programming model? So my SAP gateway will enable the content implementation to use OData features. As such, the content inherits the flexibility and complexity of OData. So the provided metadata reflects the implementation of business data APIs. Okay, so these data models can be exposed as OData services during the runtime. So the OData provides a wide range of request features such as inlining, expand, batches, paging, sorting and filtering. So the content implementation balances between the flexibility offered by OData and the technical constraints of the business functionality used. Now we can do the customization in the OData channel. So this is called as customizing. So what comes under customizing is that a SAP gateway supports multiple SAP backend systems as the providers of OData content. So since the OData content can be provided by multiple SAP systems, we must configure the connectivity between the SAP backend system and the SAP gateway system. So if the multiple SAP backend systems are connected to a single SAP gateway system, the SAP gateway system resolves potential service name conflicts. For example, many customers have local HR systems in an international system landscape. So these local systems may contain the identical SAP gateway content that is exposed by one single SAP gateway system. So the SAP gateway will provide the flexibility to provide specific URLs for the resources derived out of the SAP gateway content. So what does that mean is that we can use a single SAP gateway system for multiple SAP backend systems. Now let's see what are the OData query options we have. So for the OData query options supported by SAP gateway, there are two categories which are available. The first one are which are automatically available in the framework with no further actions needed by the development. Secondly, they are available, that means the second category wherein the query options are available but they require the implementation efforts from the development. So in the slide we can see that there are the options like select, count, expand, format, read links, value. So these all are automatically available in which there is no further development required. But the other functions, other query options, that is the order by, top, skip, filter, inline count, skip token. So all these require the implementation efforts from the development perspective. So these are the data query options which are available. Now what is the OData service lifecycle? So the service lifecycle encompasses everything in the lifespan of an OData service, from the activation and maintaining of the service via the maintaining of models and services up to the cleanup of the metadata cache. It is recommended that we should use the service builder for the applications, but a purely programmatic approach is also possible. So what does that mean is that service builder is recommended for the applications to be used, but we can also achieve the same thing using a programmatic approach, that is by using the coding. So my SAP Gateway Service Builder is the recommended tool for all aspects of service development. So we should use the Service Gateway Builder. Then we have the Activate and Maintain service. Activate and Maintain service is the central transaction for service activation. It is also accessible via the Service Builder. So we have to use the Activate and Maintain services transaction for activating the service. After that we have maintaining the models and the services. Then we have maintain annotation models. After that metadata cache. And then we have the soft state based queries result cache. So my service lifecycle includes everything from in an OData service, from the activation and maintenance till the cleanup of my metadata cache. Now, what is the activate and maintain service? So the service maintenance offers the following advantages to us. That is, it will provide a fast overview of all the registered services on the SAP Gateway Hub system as well as the backend system. It will also provide us the detailed display of a service such as Icf nodes and system alias assignment. And it is also an easy generation and activation of new services. So it is providing us the platform using which we can easily generate and activate new services. So the transaction for activating and maintaining the services is used to maintain all the registered services on the SAP Gateway server, to register and activate services, to delete services, and to simplify the usage in general. So we have to use the transaction, activate and maintain service to do everything from the start till end for a OData service. So this screen is telling us about the activate and maintain service screen window. So the main screen is divided here into an upper and a lower part, in which the upper part shows all the registered services, that is a service catalog, and the lower part shows detail of the selected service from the service catalog. So the details are further splitted into the Icf nodes and the system aliases. So this screenshot is taken from the SAP system when we are in the activate and maintain service transaction. So basically in the service catalog we will be able to see all the services which are registered, and if we select any of that service, so in the lower part of the screen we can see the Icf nodes and the system aliases for a particular selected service. So in the activate and maintain screen we can access some basic SAP Gateway functionalities directly. That is, we can quickly access the SAP Gateway client, we can quickly access the metadata cache. So the service activation results are like when we activate, the activation of an Icf node yields the main results, which are the service repository object, that is every service which is exposed on the SAP Gateway system has a corresponding repository object. So this repository object entry is used by, it can be used for various purposes, like for handling the authorizations on the service level, which can be controlled via setting the authorization object, which is s_service, and we can also use it for the external name mapping to the internal technical definition. Then we can do the routing to the backend and assignment of the system aliases. We can also do the transportation of an activated service, for example from a development or test system to a productive system. Then we have the object group. So what is the object group? So every service repository object is mapped to an object group, which is used for system alias assignment to the backend system. So as a default, the object group is assigned to the system alias from which it has been activated. Then we have the Icf node. So every service has a corresponding Icf node, which can be used for the purposes like fine granular settings of authentication mechanism and activation or the deactivation of a service. So this is basically the overview of our activate and maintain service transaction. Now let's move to the next slide. So basically then we have the SAP Gateway Service Builder. So what are the prerequisites for the SAP Gateway Service Builder? So if we have the system which is on the 7.4 or higher, so the system has the core component which is SAP_GWFND installed as standard, and it includes the functional scope of IW_BEP. So my SAP Gateway Service Builder, it is a design time environment which provides the developers an easy to use set of tools for creating the services. So the code based OData channel will consume it and supports the developers throughout the development lifecycle of a service. So my SAP Gateway Service Builder is a recommended way of creating the services. So we use the transaction SEGW in our ECC system or in our backend system on which our gateway is installed to see the service builder window. So my SAP Gateway Service Builder will cater need of both experienced as well as the less experienced developers for exposing the data for an easy consumption using a variety of platforms, frameworks and devices in a single transaction. While experienced developers have maximum flexibility to define a new service and integrate their own source code, so on the other side, the less experienced developers can reduce the time and effort involved in creating the services by importing the existing definition files and implementing the content generators. So basically, my service builder will provide us an OData compliant modeling environment for creation and maintenance of OData services without any need for programming. So my service builder visualizes all the development artifacts developers need to create a service, which includes the SAP Gateway runtime artifacts such as model provider class, data provider class model, annotation provider class and service. And it also includes the OData artifacts such as entity set, entity type and properties. So we will discuss this and what is entity set, what is entity type and what are the different properties in the later of this session. Then we have the project based service development. So my service builder introduces a new service development concept which is organized around the projects. So the projects are used to store all the artifacts that the developers need to create a service and model together in one place. So as projects consolidate all the related data, developers can easily work on multiple projects in parallel and they can reuse the data between the projects before generating and activating the actual service. So consequently, the projects provide the developers the freedom to interrupt the service development and modeling process at any time without obliging to runtime artifacts and risk of losing the data. So organizing the service development and modeling process in projects has the advantage that entire project data can be transported easily between the systems for maximum efficiency and reuse. So basically we can group all the artifacts into a single project and we can have multiple projects in which we can place our artifacts. And if the developer wants to interrupt in between the creation of a service, so he is free to do that. Now, what are the different development approaches that are there in my service builder? So my SAP Gateway Service Builder supports different development approaches and life cycles to provide maximum flexibility so that we can fulfill the changing development requirements and we can meet the diverse requirements. So if we need a service to expose a specific data, we can decide whether to define a new data model for the new service and integrate our own source code, or we can reuse and redefine the existing services. So basically in the service builder we have two options. Either we can create everything from the scratch, or we can, for the less experienced developers, they can reuse the existing services which are there in the system. So if a project exists that could be applied to a similar use case, we can create a copy of that project and then we can make the minimal changes which are required. So we can also copy the existing project which contains the artifact of some other service. So say if I want some similar kind of service, I can simply copy paste that project and can make the changes as per my requirement. So the service builder provides numerous ways of reusing the existing data sources from SAP Business Suite system. Thereby it is accelerating the development process significantly. So my service builder caters for all the levels of development experience and provides the development approaches for saving the time and increasing the efficiency without compromising the quality of my service. So whichever development approach we take, so the appropriate set of ABAP classes are generated. So this ensures that the developers have maximum flexibility while optimizing or extending the OData services in SAP Gateway. So my service builder supports the development phases for OData services, which are the data model definition, that is the model provider class, we also call it as MPC. Then we have for the service implementation, we have the data provider class, which we called as DPC, and then we have the service maintenance. So now let's discuss each one of them in detail, like what is the data model definition, what is the service implementation, and what is the service maintenance. So let's continue with the data model definition first. So in this slide we can see that the OData service definition in SAGW, that is our gateway builder. So we have it is divided into three major parts, that is the data model definition, which is MPC, then the service implementation, which is DPC, and then we have the service maintenance. So we have different functionalities which are to be achieved at each of them, at each level of these. So like we have the declarative model definition, import search help, import data model, import DDIC, import RFC BOR interface, then redefining the data source service and including the SAP gateway service. So they all comes under the data model definition. After that we have the code based implementation, code based extension, map, help operations, search. So and again redefining and including, they are shared between the data model definition and the service implementation. Then at last we have the service maintenance, in which we do the service registration. So let's see what we are doing at each level of this. So first of all, in the data model definition, so my OData services require a data model definition, that is a MPC class, model provider class. So in the case of the client development projects, the development process invariably starts with a previously defined data model. Depending on a requirement, we can define a data model in the different ways. So we can define a data model which can provide the maximum flexibility and requires manual definition of individual data model elements and their properties. Subsequent development phases, then we have the service implementation and the service maintenance as the subsequent development phases. So first of all we have the import. So there are different import options using which we can import the definition. So first of all, what is a DDIC structure? So my DDIC structure is a ABAP data dictionary which reduces the time required to create entity types and complex types in our data model. Then we have the service implementation and service maintenance, again as a subsequent development phases for this. Then we have the RFC and BOR interface. So it will enable us to reuse the existing RFC BOR parameters to create the entity types with very ease of creation. So in this way we can tap into a multitude of existing remote functional calls and business application interfaces, that is BAPIs, from the business object repository. And after we have imported an existing interface definition, we can map the operations from the same RFC or BAPI to obtain the service operations we require without having to write additional ABAP code. Then we have the import data model. So if we choose this option, it will allow us to reuse an existing data model. So we can reuse a data model for more than one service. So again it is followed by the service implementation and the service maintenance. Then we have the import search help. So it will allow us to reuse the existing search helps in a system as data sources to create new entity types. Then what is a redefine service? So redefine service will enable us to redefine the existing SAP gateway services or the services which are created from a framework within our SAP system landscape. So if you take an example of a service provider interface or the SAP BW BEX query or the generic interaction layer. So all these come under the redefining services. So the redefine service function will enable us to reuse the diverse business objects and services that exist in our SAP system landscape. Then it also connects existing service operations so that we do not need to create an individual service implementation. So consequently we can skip the service implementation phase. So we have the subsequent development phase and we have the service maintenance as a subsequent development phase for redefining the services. Then we have the include service. So my include service, it will enable me to include an existing SAP gateway service so that we do not need to recreate its data model. So for greater reuse, it will also allow us to combine one or more existing services in a new service. So if we choose to include existing services, we do not need to perform the service implementation phase. So this comprises of my data model definition, like how we can import different options, using different options, how we can like what is a redefine and what is a include service. Now let's come to the service implementation. That is, in the service implementation phase, we define the runtime artifacts, that is our operations and the methods for the data provider class. So we can define the runtime artifacts in various ways. So it can be a code based implementation. So my service builder will generate the ABAP classes based on the data model we defined. So subsequently we can navigate directly from the service builder to the ABAP workbench, where we can access the appropriate methods and write the source code for the various different service operations. So my SAP provides some code patterns for data provision and metadata definition. So what does that mean is that from the service builder transaction we can navigate to the ABAP workbench as well, wherein we can customize or write our code, ABAP code. Then we have the mapping operations to a data source. So we can define the manual relationships between the parameters of a data source object and the properties of an entity. So we can map the data sources of type RFC and BOR. So this function is designed for use in conjunction with the import data source function, and it enables us to map the RFC or BOR function to a service operation. So wherever possible, the service builder proposes an operation mapping for imported RFC or BOR interfaces. So for the DDIC tables and views and CDS views, we can implement an OData service based on the Service Adaptation Definition Language, that is SADL. So during the service implementation, we need to map the SADL model entities to the OData model properties using a mapping tool. So after that, let's come to the service maintenance. So the final development phase in the life cycle of a OData service is a service maintenance, and this must be carried out regardless of the chosen development approach. So my service maintenance entails the registering and activating each service into my SAP gateway system. So my service maintenance step is a mandatory step whichever development approach we take. So this slide is telling me the user interface of my SEGW command, that is my SAP Gateway Service Builder. So my SAP Gateway Service Builder simplifies and structures the service development and modeling process required for exposing and consuming the data by using projects. So the developers first create a project to develop, model and store all the development artifacts they need to define a service. The focus on the project-based service development is consequently reflected in the service builder user interface. So there are the different screen areas. So it is mainly divided into the three sections, that is the tree view, mass maintenance view and the message view. So on the left hand side we can see the tree view. So tree view is to show the open projects, their substructures and the artifacts they contain. So to edit the data objects and their properties, we can double click the relevant data object in the tree view. Then we have the mass maintenance view. So this mass maintenance view is for creating, editing and deleting the data objects within a project. So my data object types includes entity types, complex types, associations and function imports. So to display the details about a data object, we can select the relevant row in the mass maintenance view and we can check the details of it. Then we have the message view. So the message view will display the messages related to the status of the project. So we can hide the message view or we can delete the individual messages using this message view. So this is basically my typical interface, user interface for my SEGW command. Now, what is a service builder project? So to develop a service using the SAP Gateway Service Builder, we have to create a project. So my service builder uses the projects to bundle all the artifacts to develop a service in one central place, and thereby it helps us to organize the service development and the modeling process. So we can use the projects to organize the transports of the objects from one system environment to another so that all the artifacts remain together all the time. So basically whenever we are creating any service using the service builder project, so we first have to create a project and then we can put in our all artifacts inside it. So there are three types of projects that can be created in a service builder. So we can choose the service with SAP annotation. So if you want to annotate a data model artifacts using the standard SAP annotation, we have to choose the service with SAP annotation. SAP annotations include the creatable, updatable, label, unit property and all other things which are there in the SAP annotations. Available annotations can differ according to the data model artifact we want to annotate. We can also define the facets like nullable, default, maximum length, fixed length, precision, scale, and then the ABAP type information available includes the ABAP field name and the ABAP type editor. So basically we choose the service with SAP annotation if we want to annotate the data model artifacts using the standard SAP annotations. Then secondly, we have the service with vocabulary based annotation. So we choose the service with vocabulary based annotation if we want to annotate the data model artifacts using the terms to provide additional information about the artifact. So my standard SAP annotations are not available for this project type. So in this case, the terms can be consolidated in a vocabulary and uploaded into the vocabulary repository. So the vocabulary repository will include a set of vocabulary files such as org.odata.atom.v1 and org.odata.capabilities.v1. Then the third type of the project is annotation model for referenced services. So we choose the annotation model for reference services if we want to annotate an artifact of an existing service without modifying the service and provide additional information about the artifacts. So unlike in project type service with vocabulary based annotation, in this project type we can import another service as a reference in read only mode and then create the annotations. Now let's log into the SAP system so that we can see what all we can do in the SEGW command and how we can create the project. So let me log in to the SAP ECC system. So I'll just log into it. So by default, like I have chosen the language EN, that is for English, and then we can continue. So we have to go to the command which is scgw for my service builder. So this is my service builder, that is a SAP NetWeaver Gateway service builder interface wherein I can create the service and the projects. So let's see how we can create a project. So to create a service builder project, we have to click on this new project icon from the main menu. And after that we have to enter the name for the new project. So this project name must be unique and must not contain any spaces or special characters. However, it can contain the underscores. So my input help is available so that we can check the project names already in use. So if I click on this one, I can see the projects which are already there in my system. So basically I have to give a unique project name to my project. So I'll just close it and I can give any name, say zdemo11. After that we have to give a description for a newly created project. So this is a mandatory field and we cannot create a new project without defining a description. So my description is displayed in the service builder along with my project name. So it can be used to provide additional context information about your project. So the short description must not exceed 60 characters in length. So let's say if I give the same name, project name as a description. Now after that, under the attributes, we have to define the project type. So the project type we select when creating a project cannot be changed later. So whatever project type I give it right now, I cannot change it later on. So I can select the service with an SAP annotation if the OData service in our project is to use the standard SAP annotation. I can choose the service with vocabulary based annotation if the OData service in our project is to use the vocabulary based annotation. And after that I can also select the service, this one, the annotation model for referenced service if the OData service has to be annotated externally without modifying the service. So we can create and upload the customer specific vocabularies into the vocabulary repository. So the uploading of the vocabulary files is an optional preparatory step as there are standard delivered vocabularies available. So in this system we are getting the two options, which is the service with SAP annotation and the service with vocabulary based annotation. So let's say if I keep the service with SAP annotations. Then after that we have this generation strategy. So under the attributes we have to specify the generation strategy that is to be used. So my standard generation strategy is used by default, but other generation strategies are feasible. So if no customer specific generation strategies have been defined in the system, we can enter the standard as default to indicate that the standard generation strategy is used. So we use the standard here for the generation strategy. After that, under the object directory entry, we have to enter the name of the package in which we want to create a new project. So if we do not want to create the project in a package that is transported from one system to another system in our landscape, we can enter the $temp or we can choose the local object. So this will ensure that the object is created locally. So let's say if I want to select this local object. So now once I have clicked on that local object, so it has created, the service builder has created the new project together with an empty folder structure. So we can see the newly created project structure in the tree view in the left hand side area. So my project structure comprises of the folders and the subfolders, which are the data model, which has the subfolders entity type, association, entity sets. Then we have the service implementation, runtime artifact, and the service maintenance. So whenever we create a new project, we automatically get all these generated. So now the service implementation node is not created for the projects of type annotation model for referenced services. But since we have used the another method. So that's why we are getting this service implementation node as well. So once the project is created, we can also set the schema namespace for the data model. So the schema namespace can be explicitly set for the projects of type service with SAP annotation and service with vocabulary based annotation. So this name can be further modified. But for the projects of type annotation model for reference services, the schema namespace is same as that of the referenced service. So to save the newly created project in the service builder, we can click on this save. So now our project is saved and we can subsequently return to the service builder at any time, and we can open up this project and continue the service development and the modeling process. So if we do not want to save the project, the warning message will appear like prompting you to save the project. So say if I don't save it and I try to close the window, it will ask me that I have not saved this project, so do I want to save it? So this way we can create a project and we can save it in our system landscape. So using the service builder transaction. Now let's go back to the presentation again. So once we have created our project in the SAP Gateway Service Builder, we can start the data modeling process. So the data model defines the entity types, complex types, properties and associations required for a service. So after we have defined the artifacts contained in the data model, we can consider the operations we want to perform at runtime. And we can map these operations to the data objects and the properties within our service builder project. So at runtime, the data model is exposed to SAP Gateway services that trigger the operations we have defined at design time and return the relevant data and fields to the user. So for example, say if we have created a data model that reads the customer name, address and the contact detail which is stored in my SAP system, and a sales manager can access this data from a mobile device without logging into the SAP system directly. So there are the different data modeling alternatives we have depending on our level of experience and the time we want to dedicate to the data modeling process. We can choose the options available for the data modeling. So we can either define a new data model or we can reuse the existing data models or the services to reduce the development effort. We can also create the function imports to invoke the custom operations. We can use the generators to create the classes with the minimum effort, and also to facilitate a superior user experience when working with the service builder, we can copy and paste the functions which are available. So after that, this slide is telling me the data model definition. So basically we can define a new data model by creating or editing the individual data model elements and their properties. So in the tree view of the service builder, we use the data model folder structure to create and edit the individual data model elements. So we can create and define any of the data model element mentioned here directly in the data model folder of my project. So when we create a new data model element, it is located in the relevant predefined subfolder within my data model folder. So we can create the new data model elements in any of the following ways. Like we can double click the specific data model element in the data model folder and make the relevant entries, or we can right click the data model folder and select create and then select the data model element we want to create. Or third option is that we can expand the data model folder and right click the data model element we want to create and select create under it. So after defining a model, we have to generate the runtime artifacts. So basically like while defining the data model, we have to define all these, like the entity types, entity sets, then the association, then the association sets, after that the function import or the complex types. So this is the complete process of defining my data model. So now let's see in detail what does that mean, like how each of these can be created using the service builder. So first of all, we have the entity types. So we use the entity types in our service builder project to describe the structure of data in the entity data model. So my entity types represent a specific type of data. So for example, an item or a concept. So the entity type comprises of a unique name, a key which can be defined by one or more properties. Then we have the properties, which is the optional one. Then we have the navigational properties, which are again optional to navigate between the different associations. So my entity type properties must adhere to the data types allowed and provided by the OData protocol or be of a complex type. An entity type must have a unique identifier that allows the entities belonging to this entity type to be used within an OData context. So we can also group the entity types together in the entity sets.